This is 5.8C in elementary algebra, still dealing with story problems or applications. And we are in example number 5. Alright, so notice my triangle that I have there. This is a 90-degree angle, or what's called a right triangle. We put a little box there to show that's 90 degrees. And the key thing about a right triangle is that if we take one side and another side and square it, if we square each of the sides, we get the longest side, or the hypotenuse, squared. This is called the Pythagorean theorem. You've used this before ever since you were a little kid. And it basically means if we take one side, so let's say that this is 3 and this is 4. We take one side, 4, and square it, plus the other side, and we're going to be able to find the hypotenuse. So this is 16 plus 9 equals c squared. So 25 equals c squared. So some number times itself gives me 25. And what is that? 5. So that means that when one side is 3, the other one is 4, the longest side of the hypotenuse is going to be 5. So that's what the Pythagorean theorem does. So let's go ahead and do some story problems that include the Pythagorean theorem. Alright, example 5 says, 3 sides of a right triangle are 3 consecutive integers. So one side is x. Consecutive means they're just one right after the other. So if we know one is x, if we know one is 4, then this one's going to be 5 and this one's going to be 6. Consecutive. We just added 1. And notice, we could have said one number is x, one number is y, one number is z. But how do we put all those together? We only know how to work with one letter at a time. In Algebra 2 and maybe even Algebra 1 later on, we'll learn how to work with 2 variables like x and y, but at this point we only know how to work with one at a time. So what we're going to do is we're just going to write them that way. So 3 sides of a triangle are 3 consecutive integers. Find the lengths of the 3 sides. Alright, so I know that this is the longest side, right? So that has to be the hypotenuse, because the hypotenuse is always the bigger number. And then it doesn't matter which the other ones are. We can put that as x plus 1 and that x, or vice versa. But I know that the 3 sides of a triangle are 3 consecutive integers. Find the lengths. Well, there's not really a whole lot of options there for lengths. All I know is that if I take the first one and square it using a squared plus b squared equals c squared, using Pythagorean here. Might be nice if I made a 2 that looked like a 2. Alright, so there's my first one. So if I take that one and square it, and add that one and square it, I'm going to get my longest one squared. Boy, that looks kind of hairy, doesn't it? So, do you see what I did there? I took my first length and squared it, my second length and squared it, and compared it to my third length, or my hypotenuse squared, which is what this formula says. Okay, so let's go ahead and use my FOIL right here. So I just did FOIL in my head. Alright, now let's use FOIL again. Okay. So now we got a whole bunch of stuff. So let's put these two together. And these are kind of tricky, aren't they? I'm trying to get x all by itself. Well, let's set it equal to 0. So let's move all of these over this way. And the way we do that is we just take all of them and move them over and change the signs once we move them over. So okay, we're going to change the side of that to a negative now since it's positive. Change that to a negative. change that to a negative, and that can equal 0. Okay, so we just moved them all to the other side. So let's combine our like terms. 2x squared minus 1x squared is 1x squared, and those go away. Positive 2x minus 4x, take the difference between the two since one's a positive, one's a negative. And now we have a positive 1 and a negative 4. Signs are different. We take the difference, put the sign of the largest one on there. Wow, we took that big old mess. Okay, come on. Let's move some of this out of here. And we have this left. Can we do this? I don't know. Are there two numbers multiplied together that give me 3, added give me 2? Yeah, 3 and 1. 3 times 1 is 3. And when we add them, I've got to get a negative 2, so that means the largest number has to be negative. So, x minus 3 is 0, or x plus 1 equals 0. Over here, x is 3. Over here, x is negative 1. Okay, so when we look at this, one thing to realize is we cannot get the length of a side as a negative, so that one goes away. So, x equals 3. Alright, so we were looking for x plus 1, and x plus 2. So if one length is 3, the other length is 4, and the hypotenuse, or the longest length, is 5. So there's the lengths of those triangles. When you have 3 sides that are consecutive, that's what those lengths are. Those are the only lengths that are consecutive in the whole history of triangles. 3, 4, 5 triangle. And they use it in construction a lot because they always know 3, 4, 5. Okay, let's look at example 6. Okay, example 6 says the hypotenuse of a right triangle. So make sure you're familiar with these words. A right triangle. The hypotenuse is 5 inches. Longest side. The lengths of the two legs are given by 2 consecutive integers. So consecutive integers is x and x plus 1. So one of these is x, one of these is x plus 1. Okay, not too bad. Find the lengths of the two legs. So we're trying to find out what x is to find this leg, and to find this one we'll find x and then add 1 to it. So we've got, going to use Pythagorean again. So in other words, one side squared plus the other side squared equals the hypotenuse squared. So this is x squared. Use the FOIL method to square those. And 5 times 5 is 25. Let's combine those two. Okay, we've got to set it equal to 0. So I'm going to subtract 25 from both sides. And 2x squared plus 2x minus 24, when we put these together, gives me 0. Okay, so all that work to get that equation. This is the equation we're going to work with. Okay, now I have to solve for x. Alright, so what you're going to do here is look for some handy little tricks here. We have done 2 times negative 24, and then we get 48, and then find two numbers multiplied together give you 48, added give you 2. You can do that. But one of the first things you want to look at is there something I can pull out of there? Is there something I can factor out of there before I do anything else? And there is. Whoops, that's not a 2, that's just an x because I pulled the 2 out. I pulled a 2 out of the 24, leaving me with 12. Now this one is a lot simpler to deal with. I don't have a number in front of my x squared, so I don't have to do any grouping or anything like that. I can just take this, draw it that way. Leave the 2 there, but two numbers multiplied together give me 12, added give me 1. So 4 times 3 is 12. 4 minus 3 is 1. So I'm going to put, I need to get a negative when I multiply the 4 and the 3. So with that being the case, I have one answer, or one number that's negative and one positive, so that when I multiply I get a negative. And I've got a plus sign here, so my biggest number has to be positive. So that tells me where the positive goes. So I've got x plus 4 equals 0, and x minus 3 equals 0. So x equals negative 4 and x equals 3. Okay, so again, one of our lengths is negative 4. It can't be, so that means that one doesn't work. So this one says one of our lengths is 3, and one of our lengths is 3 plus 1. And that gives us, again, another 3, 4, 5 triangle. So that gives me the answer there. So that's example number 6. So we'll go on to one more video and we'll be done. We'll do examples 6, 7, and 8.